Thanks.
Okay, so how can we tell from this molecular formula if it is saturated or not? We first have to rewrite this molecular formula as a structural formula so that we can see what's happening with the molecule. So I'll switch over to my whiteboard on here. Okay, can everyone see what's happening? We have our compound, which is CH3, CCC, H2CH3, CCC, H2CH3. This is the molecular compound of this molecule. So now we have to write the structural formula and see what's happening. Now we can count the number of carbons first in order to have our chain and see what's happening. 5. And here we have 5 carbons. So we place our 5 carbons. And now we look at what's happening around those carbons. This first carbon here is attached to 3 hydrogen atoms. And so we label these hydrogen atoms. This carbon is attached to this carbon. So we can leave it as is for now, and we'll come back and see what's happening. This carbon is also attached to another carbon, which we have over here, but we don't know what's happening yet. And this carbon, let me label this carbon 1, carbon 2, carbon 3, carbon 4. Carbon 4 is attached to 2 hydrogens. And so we label those hydrogens, as well as a carbon over here, which is what we have here. And this carbon is attached to 3 other hydrogens. And we label those hydrogens. So in organic chemistry, when we are first introduced to what it is and organic compounds, we are introduced to the carbon atom. And one of the properties of the carbon atom is that in its outermost shell, it has 4 valence electrons. So that means that it can bond with something 4 times. So here we can see that this carbon right now is bonded to 2 things, and this carbon is bonded to 2 things. That means that there are something else that are short. So if we complete this with 2 more bonds, we can see that this carbon is attached to 4 things, or its 4 valence electrons have been occupied. We have this bond over here, and this triple bond over here, which makes 4 bonds with this carbon. And then we also look at this carbon and see how many bonds are around it. There is 1 bond over here, and there's also 3 other bonds. So now our question was asking us if this molecule was saturated or unsaturated. Our answer is that it's unsaturated. Why? It is because of this triple bond. Okay. So our next question was asking us, oh, sorry. Okay. Then question 2.2 asks us to write down the letter that represents each of the following. 2.1, we have an ester. 2.2, we have a functional isomer. 2.3, we have a compound with the general formula CnH2n-2. And 2.24, we have a compound that is used as a reactant in preparation of compound D. So what is this compound D they're talking about? It's this butyl propanoate. Okay, so now we will switch back to the whiteboard in a minute. Okay, so the first question asks us to match one of those compounds to an ester. So what do we know about an ester? So an ester is a molecule that, for one, it has the suffix OH, and it has a double bond and an O. So what this means is that, switching back to the whiteboard, we're looking for following. So we don't have something that shows that molecular form. Point 2.2, we are looking for a functional isomer of butanol. Firstly, what is a functional isomer? Well, a functional isomer is an isomer that has the same molecular formula, but the atoms in that molecule are arranged or connected differently. So we're going to be looking at butanol, and then we're going to look at options of butanol, or options kind of looks like butanol but isn't exactly butanol. So what is butanol? Butanol is an aldehyde, and sorry, apologies. Okay, can you see the whiteboard? Okay. Butanol is an aldehyde with 4 carbons. How do we know it's an aldehyde with 4 carbons? Because of the but in butanol. So we have a butanol here. Structural formula. One, two, three, have 4 carbons, and one of these carbons at the beginning could have our double bond O, single bond O, and we'd have something that looks like this. As our butanol. I think this is hydrochloric acid. Carboxylic acid. Might be incorrect there. Okay, I am incorrect. Functional isomer of butanol. Sorry, my apologies. This is an aldehyde. It has a C double bond O and double bond H as its functional group. The aldehyde functional group. And we can look at the chemical formula of this. So we have our 4 carbons, which is C4. Properly, our C4, And we have 1, 2, 3, 4, 5, 6, 7, 8. Have H8 and an O as our molecular formula. We might need to use it, we might not need to use it, but we can put it in the back of our minds for now. So what we are looking for is a compound that has a structural formula that looks like this, but isn't exactly like this. What we are looking for is something that will have a double bond O somewhere and also have the same numbers of H's, of hydrogen atoms. And in our question paper, what we have, or what we can see, is that B is the one that satisfies that. We can see that we can count the number of carbons in B. We have 1, 2, 3, 4 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, and we also have an oxygen. So our functional isomer of butanol would be B. Then C asks us to look for a compound, to write the letter of a compound that has the general formula of CnH2n-2. So within the first functional groups that we learn about alkanes, alkenes, and alkynes, what we know about alkanes, they're a functional group with the formula CnH2n+2. Alkenes, which are the ones with a double bond, have CnH2n, and alkynes, which have a triple bond, have CnH2n-2. So in our question paper, we're going to be looking for something that is an alkyne or something that has triple bonds. And from our question, or from previously, we have seen that C was the compound that had triple bonds. So C is the compound with the general formula CnH2n-2, which corresponds to the alkyne functional group. And so 2.2.4 asks us to look for the letter that represents a compound that is used as a reactant in the preparation for compound D. So what is compound D? Compound D is butyl propanoate. So what is this butyl propanoate? Well, firstly, it is an ester. And how many carbons does this ester have in its main chain? We have this propan, which is attached to this O8. This propanol, or this propane, that is attached to this ester over here. And prop represents 3 carbons. And this 3-carbon chain molecule is attached to this substituent over here, which is butyl. Butyl is basically butane as a substituent. If butane stands alone, it's just 4 carbon atoms. There's single bonds within those carbon atoms, and there's hydrogen atoms attached to those carbon atoms. But as a constituent, it's butyl. So what this means is that, so we have this butyl propanoate. The parent chain, in order to determine what the parent chain is, we look at the second part of the IUPAC name of a compound. And here we have this propan here, which means that we have 3 carbon atoms. But it's a propanoate, and there's no other number or anything else that's here. So we know that it's an aldehyde that looks like this. Oh, okay, this. This. That's the propanol. And this butyl, which is the first part here, represents the substituent, which is what is attached to the parent chain of this butyl propanoate. So we have the prop parent chain, hydrogen, 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 hydrogen. It's attached to butyl, which is 4 other carbon atoms. 1, 2, 3. Okay, there's no space here. Next strip. This one. And because it's a butyl, that means that it's an alkane substituent. Know that there's all H's here. So our question was asking us for a compound which is used as a reactant in the preparation of compound D. Which is, oh, sorry. Okay. The session will end in 10 minutes. We'll have a short break then, which is this one. A. We needed something that combined with something else to give us this butyl propanoate. And why is it A? Because A over here has 4 carbon atoms. And this reacted with a carboxylic acid to form this butyl propanoate. Are there any questions about that? Or is everyone fine? Okay, you can type in chat if there's a question about something that isn't clear. Okay, so 2.3 asks us to write down the structural formula for the functional group of compound C. Now, we have established that compound C was an alkyne, because of that triple bond. That alkyne or that triple bond is its functional group. So if we're going to write down the structural formula of the alkene, it will basically be this. This is the structural formula of an alkyne because it indicates the triple bond. And this triple bond is the functional group. Okay. Question 2.3.2 asks us to find the structural formula for compound D, and then it asks us to also find, that's 2.3.2, 3 asks us to find the chain isomer for compound A. So compound D, which is the butyl propanoate, 2.2. Butyl propanoate, I think we've already also done it here, which is this one. And we'd have to include the hydrogen atoms as well. The next question asked us to find a chain isomer for compound A. So what is this chain isomer that it's asking us about? Well, a chain isomer or chain isomers are molecules with the same molecular formula, but they have different arrangements of their carbon skeletons type of thing, or their carbon chains. So what's happening with this compound A? So compound A over here, we can see that it has 1, 2, 3, 4 carbons, and each of those carbons is attached to a hydrogen. So what does A look like? The structural formula for A. So the structural formula for A looked as follows. We have all of the carbons attached to two hydrogens, and there were 4 carbons. So this is how A looks like. It's supposed to be hydrogen over here. So a structural isomer of this compound would be to change any position of one of the carbons and make it look different from what it looks like now. So as our carbon looks like it's attached, it looks like this square shape or whatever, we can change it and make it to look like this. For example, this would be a structural isomer of A. Why? Because as we can see, this chain has a different shape from this chain, but we didn't change the number of hydrogen atoms that are attached to all the carbons. If we can count all the hydrogen atoms here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. And then we count the hydrogen atoms we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We didn't change that we have the H10 and C4. We also have C4 and H10. So structural isomers are molecules that have the same molecular formula, and the structures are different in terms of the chains or the carbon chains in their structures. So one of the solutions to 2.3.3 would be this one. So to answer 2.3.3, you have to change at least one of the positions of the carbon atoms that are in the molecule of A. Okay. And then question 2.4 asks us to find the IUPAC name of compound F. And then 2.4.2 asks us to find the balanced equation using molecular formulae for the complete combustion of compound A. So we have the compound F over there. So what's happening there with compound F? So what we can see with compound F is that it's got this long carbon chain, which will count how many carbons that it has. It has the hydrogen atoms attached to carbon atoms, but some of those hydrogen atoms, but in some of the positions where there would be hydrogen atoms, we have these bromine atoms attached there. So when looking for the IUPAC name of a compound or a molecule, you first count the number of carbons in the chain. So whatever long the name of the parent chain will be determined by the longest carbon chain. So what we mean by that is that you count the number of chains, the number of carbons you have in a chain. So our chain could go like this, which is horizontally, or it can go horizontally and then turn and go vertically. So we'll count the number of carbons and see which carbons are the longest chain. So we'll have 1, 2, 3, 4, 5, 6 carbons if we consider the horizontal line as our chain. And if we consider starting from the carbon atom over here, and we count 1 carbon, 2 carbons, 3, 4, 5, 6, 7, whatever is the longest chain is the one that determines that parent part of the IUPAC name. So since we have established that the 7 carbons make the carbon chain, our parent name in the IUPAC name will have a hept. So we have less than 1 minute and the video is going to cut, but then we'll come back like after 2 minutes. So it's going to be a very short 2-minute break, and we'll come back to continue this question and the rest of the questions that I have prepared.
Leila too.
Yes?
Who starts the meeting? Is it me or you?
It's going to be you once it cuts, because you're the one who has the link and the join link and everything. So we're going to have to join back again, and then you're going to have to change me into the host again.
Okay, that's fine.
Okay. Okay, so we'll have a very short 3-minute break.